Alright, welcome back guys. So now, watch the first video. Now we're going to be doing it when the other side is not 0, when it's something greater than 0. So let's start with this first problem, alright? So we'll call this number 4, we can redo number 1. So let's say you have 3x plus 1 over x plus 4 is greater than 1, not 0, 1. Okay, the first thing you have to do in order to solve this, you have to make the, it's greater than or equal to, excuse me. First thing you have to do before you do this, you have to bring the 1 over, you have to make one side 0. So what I'm going to do is, I'm going to subtract this 1 on either side. So this says greater than or equal to 1. So what I'm going to do is, I'm going to subtract this 1 on each side. So I'm going to get 3x plus 1 over x plus 4 minus 1 is greater than or equal to 0. Alright, so you make one side 0 first, so you bring that number over, whatever it is, over. Alright, so now what we have to do is you have to make a common denominator in order to make this all one fraction. So what I'm going to do here is, the common denominator here, of course, is 1 over 1, so the common denominator here is x plus 4. So what I'm going to do is, I'm going to have 3x plus 1 over x plus 4 minus x plus 4 over x plus 4 is greater than or equal to 0. So all I did was, I had to multiply x plus 4 to the bottom here, so I also have to multiply it to the top. So that's why. You don't cancel these out. You don't nothing to cancel. I just made a common denominator. So this denominator became x plus 4, multiply that to the bottom, I also multiply it to the top. That's why it also became x plus 4. Now I'm going to make this all one fraction. So it's all going to be over x plus 4. Alright. So now I have to just combine 3x minus x is going to be 2x. 1 minus 4 is going to be negative 3. So now I'm going to be solving with this. So once you create one fraction, that's the hardest and the other step we have to do in these. Once you create one fraction, now you're just solving this like we just did every other problem, alright? So we know, alright, so if I just get rid of this side, okay, you get this side down real quick. So if we just continue this problem over here, okay, I now have to figure out, now that I have this one fraction, I have to figure out where the numerator and denominator are 0 and create my number line. So the numerator is going to be 0 at x equals 3 halves. And the denominator is going to be 0, denom, is going to be 0 at negative 4, x equals negative 4. Alright, so I'm going to have two values I'm looking at, right? So I'm going to have, and you can estimate the 1.5 as best you can, 3 halves is 1.5. So here's 0, here's 1, 2, 3, here's 1.5, right? And then negative 1, negative 2, negative 3, negative 4, negative 5. Alright, so you're going to have three regions you're going to look at. So see, you have negative 4, which is not part of it, but it's where the denominator equals 0, and 1.5. Alright, so we have three regions we got to test. We got to test past negative 4, in between, and then past 1.5. Alright. So, if we plug in anything, so it has to be greater than or equal to 0. So if I plug in negative 5, I'm going to get negative 13, it's going to be positive 13, which is greater than 0. So negative 4, everything less than negative 4 is going to work. Okay, good. If I plug in the middle here, if I plug in 0, if I just plug in 0, it's always easy. I'm going to get negative 3/4, which is less than 0. So I just plugged in 0 here, and that's not going to work. So I just plugged in 0, and that's going to give me, that's going to be less than 0. So this interval doesn't work. Now here I'm going to plug in 2. If I plug in 2 to this thing here, to this one, all right, we're working with this now. If I plug in 2 here, I'm going to get 1/6 is greater than 0. Okay, so what does it look like? It looks like everything from negative 4 and less than negative 4 works. Everything from 1.5 and everything greater than 1.5 works. Okay, well, what does that mean? Remember that if I keep going this way, this is going to be negative infinity. If I keep going this way, it's going to be positive infinity. So here's my answer I'm going to write. Since we get that, I'm going to have x is greater than negative infinity and less than 4. Alright, negative 4, sorry. So x is going to be everything, like everything between negative infinity and negative 4, so everything from negative 4 down. And I'm going to have x is going to be less than or equal to 1.5 and less than infinity. Okay, you're asking me, why did I put the equal to with the 1.5 and not with the negative 4, not with the infinities? First off, x is never going to be equal to infinity, so it's never going to be equal to the infinity, so it's always going to be less than or greater than with the infinities. The reason it's not equal to 4, negative 4, is because remember, negative 4, if you plug that in here, makes this undefined. Remember, we can't divide by 0. But 1.5, it can equal. It just equals 0 when it's 1.5. The expression would be equal to 0. So 1.5 is part of my solution set. So everything that's 1.5 and greater, and all the way to infinity, is my one half of my solution set. The other solution set is from negative 4 and less than negative 4, but it's not equal to negative 4 because negative 4 makes this undefined. All right? This is my first solution then. All right? And I have to check each region. Okay? I know it's annoying. I have to check 4 regions. Just plugging numbers in and checking. So I plug one number in from here. I plugged in negative 5. I plugged in 0 here, and I plugged in 2 there. All right? All right, so now we're going to do one more, where the one side is not already 0. All right? Now, if for some reason that didn't say equal to 0, then 1.5 wouldn't be part of my solution because it couldn't equal 0. It had to be actually less than 0. Pay attention to what you're looking at. Again, all right, so let's look at one more. All right, so let's say I get this one, all right? So I get x minus 8 over x is less than or equal to 3 minus x, right? All right, so what we have to do first is I'm going to bring the x and the 3 over. So what's going to happen is when I bring those over, I'm going to add x, subtract 3. So I'm going to get x minus 8 over x plus x minus 3 is less than or equal to 0. So I just added the x over, subtracted the 3 over. All right, so remember that this is all over 1, okay? When I bring this over, it's over 1. So what I have to do is I have to make a common denominator here first, make it all one fraction. So what's going to happen is I'm going to have x, the common denominator is going to be x, right? That's all they have, x and a 1. So it's going to be plus x times x minus 3 over x is less than or equal to 0. All right? So what I have to do is distribute the x out there. So I'm going to have x minus 8 over x plus x squared minus 3x over x is less than or equal to 0. So I'm making this all one fraction. Let's combine what we have. So that's going to be, put the x squared in front. 1x minus 3x is going to be negative 4x minus 8 over x is less than or equal to 0. All right? So, it's positive 1 minus 3 is going to be negative 2. Sorry about that, guys. All right. Factor. So I get x minus 4, x plus 2 over x is less than or equal to 0. Right? Because negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So my numerator is going to equal 0, right, at 4 and negative 2. And also my denominator is going to equal to x equals 0. All right, so I do my number line. All right. So I have here's 0, 1, 2, 3, 4, just go up to 5. Then I'm going to do negative 1, negative 2, negative 3, and there. All right, so now I draw my regions, right? So I have a region at negative 2, 0, and negative and positive 4. All right, so still again, all right, still not again, sorry. So I plug in negative 3, right? Plug in negative 3, I get negative 7/3, which is less than 0. That works. It needs to be less than 0, so I plugged in negative 3. All right, now here I'm going to plug in negative 1. I'm going to get positive 5. That's going to be greater than 0. That doesn't work. You need to be less than or equal to 0. If I plug in the middle between 0 and 4, if I plug in 1, I'm going to get -3, and that's less than 0. So that works. You can plug in any number. I'm plugging in 1 in that case. And then here, I'm plugging in 5, and I'm going to get +7/5, which is also greater than 0. So that does not work. So you need to find the places where, when I plug in a number in this area, I get a number that's less than 0. You can plug in any number you want. In this case, I think I plugged in -3, -1, 1, and 5. Doesn't matter. Any number will do. So in this case, I have two regions where my inequality works. So first off, remember this is -infinity. This is +infinity, right? So from -2 to -infinity, it works. All right, so I'm going to rewrite this as, so my answer, I'm going to erase this top part here. So my answer is going to be, x is going to be between -infinity, remember it's always going to be less than, it's going to be greater than -infinity, and less than or equal to -2. Again, it can be equal to -2 because it doesn't make the bottom 0, so that works. And there's another thing from 0 to 4, right? And x is greater than 0 and less than or equal to 4. Now again, why is it less than or equal to 4? Because 4 you can plug in. Okay, 4 is not going to give you a 0 denominator, but if I plug in 0, it's going to make the function, not the function, but the expression undefined. So that's why it's greater than 0, but less than or equal to 4. All right, there's my answer to that. So there they are. So there's two problems when one side is not 0. All right, have a great day, and yeah, have a good day.